Good morning. Let us see today what are biomolecules. Oils and fats are one of the biomolecules. They are of biology. They are obtained from plants and animals. Oils and fats are obtained from plants and animals. Okay. What are oils and fats? Oils and fats are nothing but triglycerides. Oils and fats are nothing but triglycerides or triglyceryl esters of glycerol. Triglyceryl esters. Okay. So, what is the composition of oils and fats? This is the structure of oils and fats. It consists of, if you look at this, it consists of a molecule of glycerol and 3 fatty acids. See, this is glycerol. This oils and fats consist of glycerol and 3 fatty acids. Okay, how it is obtained from? How it is prepared? It is prepared from glycerol on reaction with the fatty acids. 3 molecules of fatty acids. What are fatty acids? For example, fatty acids are obtained from fats. And the alkyl groups are long. The alkyl groups are long chain. Alkyl group. Okay. Now, on reaction of alcohol plus organic acid will give ester. Okay. So this is again glycerol on reaction with fatty acid in the presence of dehydrating agent. Such as concentrated sulfuric acid, a drop of concentrated sulfuric acid or a pinch of P2O5, it will give triglyceryl esters. They are nothing but triglyceryl esters of glycerol. Okay. Now, this is the composition structure of oils and fats. Okay. Now let us see saponification of oils and fats. One of the chemical reaction of oils and fats. This reaction is also called soap forming reaction. This is how soap is prepared, manufactured. This is how soap is made. Take oil or fat in a container and add sodium hydroxide solution, concentrated sodium hydroxide solution to the vessel and heat it. On heating, it will undergoes hydrolysis, as you see HONA, and it gives here, therefore hydrolysis, the breaking of bond, the breaking of water or breaking of OH bond. Therefore, it is called saponification reaction is also called hydrolysis of oils and fats or esters. In the presence of alkali is called saponification reaction or called soap forming reaction. Okay. This reaction, this ester hydrolysis is carried out in the presence of alkali or in the presence of base. For example, sodium hydroxide or potassium hydroxide, you will get glycerol and soap. What are soap? Soaps are nothing but sodium or potassium salt of fatty acid. This is fatty acid. Sodium salt of fatty acid or potassium salt of fatty acid. If you take potassium hydroxide, then you will get potassium salt of fatty acid. Okay. Or in this case, or is the long chain alkyl group. If R1 R2 equal to R1 equal to R2 equal to R3, please write. It is called simple glycerides. If R1 not equal to R2 not equal to R3, then they are called mixed glycerides. Okay. In the fatty acid, alkyl groups are long chain. For example, formic acid HCOH. It is also an acid, but it is not a fatty acid. It is an organic carboxylic acid. It is not fatty acid because it is not present in fat and the alkyl group is not very long. Formic acid, for example, acetic acid CH3COH. It is also not a fatty acid because it is not found in fats. Okay. Now, if you look at the structure of fatty acids, this is the sodium salt of fatty acid, or if you put COH. Okay, there are two ends. One is, if you look at this, it is the skeletal form. It is the actual structure form. It is the skeletal form. And this is hydrocarbon end, and this is polar end, polar group. COO minus. This is a polar end. So head group, polar end is called, this polar end is called head group. It is soluble in water. This end is soluble in water. Therefore hydrophilic, water loving. This is water loving group and this is water hating group. Therefore hydrophobic. Phobic means hating. Water, hydro means water, hating group. This is lipophilic. On the other hand, this is lipid loving group. This is lipid soluble group or lipid loving group. This is water soluble group, hydrophilic. This is the tail and this is the head. There are two ends. There are two ends. One is hydrophobic tail and another is hydrophilic head. Okay, now let us see what is salting out of soap. See, when you prepare, when you carry out the saponification of oils and fats, soap is formed. When the saponification is carried out, okay, soap is formed due to ester hydrolysis, in the presence of sodium hydroxide. The soap is soluble in water. See, the soap is soluble in sodium in water. Therefore, it is not precipitated out. It is not salt. How it is precipitated? How the soap is separated from the mixture? By adding sodium hydroxide. You see, by adding sodium hydroxide to the mixture, and stir it, soap will precipitate. Soap will salt out. Okay, soap will precipitate out. How it is? For example, what are the equilibrium? What are the reactions? Or this is RCOO, sodium salt of fatty acid, equal to, in the presence of water, it dissociates to give RCOO minus Na plus. On adding NaCl to the solution, to the mixture, NaCl gives Na plus and Cl minus. Now, you see, Na plus is common. Na plus is common with the one of the products. One of the ion we add is common with the product. Therefore, the equilibrium or the reaction will shift to the left. Because of the common ion effect. The equilibrium or the reaction will shift in the left hand direction due to Le-Chatelet-Brown principle. Or if you add reactant, the reaction will shift to the right. If you add one of the product, because the ions are common, the reaction will shift in the reverse direction, backward direction. Due to common ion effect, the equation, the reaction will shift left. Therefore, soap is precipitated out. Now, what are hard soap and soft soap? Hard soap, sodium salt of fatty acids, they are not very much soluble. They are called hard soap. And whereas potassium salt of fatty acid are called soft soap because they are highly soluble. And potassium hydroxide, if you use potassium hydroxide, you will get potassium soap. The potassium soap is, and potassium hydroxide is costly. Okay, potassium soap is for kids, children. It is used for kids. Okay. Now, what are the differences between oils and fats? Give the differences between oils and fats. Triglycerides are liquids at room temperature. If the triglycerides are liquids at room temperature, then they are called. Then the triglycerides are called oils. If the triglycerides are solids at room temperature, for example, fats are solid at room temperature, whereas oils are liquids at room temperature. Okay, so low melting point. The melting point of oils are low, whereas the fats have high melting point. They are high melting. Next, oils consist of unsaturated fatty acid. See, the fatty acid, unsaturated fatty acid. It consists of one molecule of glycerol and 3 molecules of fatty acids. Okay, but they combine to give triglycerides, oils and fats. It consists of unsaturated fatty acids. What are unsaturated fatty acids? Unsaturated fatty, they consist of carbon-carbon double bond. Remember, they contain carbon-carbon double bond. For example, oleic acid, there is one double bond. linoleic acid, there are two double bonds, unsaturated fatty acid. Whereas fats consists of saturated fatty acids. There is no double bond. There is no carbon-carbon double bond in saturated fatty acids, stearic acid, palmitic acid, etc. Next, examples. What are the examples for oils and fats? Coconut oil, sesame oil, linseed oil, mustard oil, soybean oil, corn oil, etc. They are of vegetable origin. They are obtained from vegetable seeds. They are mainly obtained from vegetable seeds. Okay? So they are of vegetable origin, whereas fats are animal origin. Fats are animal origin. For example, animal fat. They are solid, very solid at room temperature, and they are high melting. They consist of saturated fatty acids, lard, and butter. For example, butter is obtained from animal milk. Okay. So these are the what are the sources of oils and fats. We have seen why oils are liquids. Why oils are liquids at room temperature? Because it consists of unsaturated fatty acids. Why fats are solids at room temperature? Because it consists of saturated fatty acids. What is salting out of soap by using common ion effect principle, by adding one of the products, by adding sodium ion, sodium chloride, it will give a sodium ion, which is one of the products. Therefore, it shifts the equilibrium, or it shifts the reaction to the left. And what is the structure and the composition of oils and fats? If R1 equal to R2 equal to R3, then simple glycerides. If R1 not equal to R2 not equal to R3, then they are called mixed glycerides. In general, oils and fats are mixed glycerides, not simple glycerides. We have seen how soaps are produced, and okay, what are hydrophobic tail, what are hydrophilic heads. Okay, thank you for watching.